Stingrays! Look at that perfect timing from our stingray friends. Welcome to the Aquarium Online Academy. My name's James. We're going to be talking about the pancake shark of the ocean. What? Pancake shark. I said it. You heard it. We're going to talk about rays and stingrays and their friends. Not unicorn fish. Not the Queensland grouper. We're going to be talking about that. But this isn't just going to be me talking. You get to participate. So if you're watching live, text us questions and observations right there at 562-286-1838. We'll get to put those into the studio. Jen's on question control. She'll be bringing them in so we can answer your questions, what you want to learn more about. And Carrie's going to show off all the fun things on the screen behind me here. Let's make some quick observations about one of the biggest spaces we have here. Actually, this one is the biggest that we have right now. Stingray. What else can we notice about our big tropical habitat? We know the stingrays live in there. That was one of our eagle rays right there. What else can we observe? Now, I will tell you, if you've been watching this webcam before, there's been some remodeling going on in there. Jen is describing the eagle rays as like reverse blueberry pancakes because in a blueberry pancake, the spots are blue, but on a eagle ray, the spots are white. Good observation. She's saying the blue spotted rays. They do look like pancakes. We'll show you some later. Here is our southern stingray. So there's two species of ray we found in there. We actually have another species in here. Right there. That is the mangrove ray. So that's 3. Ooh, who else can we find? Is there another species of ray? There's that little one. That is the cownose ray. That's 4 kinds of stingray in this space. So not only do coral reefs have a lot of other fish living in them, they have these really beautiful rays too. So what makes a ray a ray? Why do we consider them a pancake shark? Why are they not like other fish? Well, if we look at a stingray, they have very similar body features to sharks in a couple of ways. The one we can't see is their skeleton. They have a cartilage-based skeleton. Where's the cartilage in your body? Right here. Right here. And then where's the bones? Like our long bones, our arm bones and leg bones, those are hard bone. Cartilage is very soft and squishy. So sharks and rays have cartilage in their skeleton, and all these other fish that aren't sharks and rays have hard bones in their body. Now there's our species of shark hanging back there. We also have the zebra shark we just saw a minute ago. So sharks and rays belong to one group, the elasmobranchs. They have a cartilage-based skeleton. They have some distant cousins called the ratfish who have a cartilage-based skeleton, but they're not rays or sharks at all, so they get kind of this extra branch to the family tree. Then you look at the way we would divide sharks and rays out. Rays have their gills underneath their body. So this shark, if you got to see it up close, the gills are on the sides, and then a ray, the gills are underneath. So if you look at the side of a fish and a shark, their gills are on the sides, whereas the gills will, for some of them, will be underneath. Now I think we have a picture of the underside of a bat ray we might be able to show you to give you a little better looks like, or a cownose ray. We can look at them too. So you look at the underside of a ray, not only are they very smiley animals, but they have these gill openings right here. So rays have their gills underneath them, sharks have their gills on the side. Some rays have very similar features to a shark. They have a body like a shark, they have vertical fins like a shark, but their gill openings are underneath. So they count as a type of ray. Now when you look at rays, we can divide them into a lot of different groups. We have stingrays like this one here. We have non-stinging rays like a Manta Ray or a mobile ray. And then we have things like skates and guitarfish too. So lots of different animals belong to the ray group. We just kind of generically call them all rays, but there's a lot of division in this family tree. And the way we divide them into different groups is how they have babies. So we can divide skates and rays apart from each other in a couple of ways. The easy one is how they have babies. Rays will have live birth, Skates will lay eggs. And then they also have some other body differences. So skates might have similar shapes. They tend to be a little bit more elongated, and their fins don't connect right up next to their eyes. Their fins would actually connect a little bit closer to like what we consider a shoulder. But then the stingrays have a stinging part of their tail, and skates don't have that. Skates have thorny ridges down their back. All right, so now let's look at a guitarfish. We have one called a masked ray, which is got the name of ray, but it's actually a guitarfish. It's okay. Remember, we just generically call them rays. Now, the masked ray, which is a guitarfish, has similar body designs to a skate. And the one we're going to look at is kind of hiding, but we're going to find it. Don't worry. You have very amazing observation powers. Where's the animal in here? Did you find it yet? Oh, I noticed something right here. Here's an eye. That must be part of our fish. So the masked ray, oh no, this is a Fiddler Ray. So the Fiddler Ray and well, I got that wrong. The Fiddler Ray is a guitarfish. The masked ray is an actual ray. The Fiddler Ray has this pattern to their body, so they have camouflage. They hide under the sand, just like stingrays would. But if we got to look at the whole body of the Fiddler Ray, they have some vertical fins. Guitarfish have that, but they have babies like a stingray, but they have a body like a skate. So guitarfish kind of get this in-between combination of features between skates and rays. Now, while we're watching this picture, this is a really important part of sharks and rays. Not the eye, that spot right behind the eye, that's called a spiracle. So all the sharks and rays have spiracles, but not all of them are they visible on that animal. So a great white shark has spiracles, but they're so reduced in size you can't even hardly see them. But rays still need them. Remember where the gill openings are for a ray? Are they on the sides? No. The gill openings for a ray are underneath on the what you would think of like the chest. Well, if it was breathing water in through its mouth over here and trying to breathe out, would this Fiddler Ray be able to breathe easily? Or would it might maybe accidentally vacuum in some rocks while it's breathing? They don't want to do that. When the rays are hiding in the sand, they don't want to inhale the sand either. So what this does is it provides like a little nostril on the back of their head that they can breathe while submersed in the sand or the rocks without letting any other animal know where they're at and without inhaling some of that material too. So that's pretty cool that they can use these kind of like a nostril or like we use a snorkel so we can get to the water behind the animal. Good question of do they all live in the bottom of the ocean? A lot of rays like to be in the sand or in the rock, but there's a bunch of rays that will live out in the open ocean. Actually, that cownose ray we were looking at previously, they will migrate through the open ocean. There's pictures of cownose rays in large groups of hundreds of rays, and it almost, if you look down at the water from like a helicopter, it would block out from looking down at anything else. So imagine hundreds of these swimming together. You could see their kind of sandy, tan, brown bodies in the water, and it just kind of covers everything. So they will sometimes be out in the open ocean, moving from place to place. Other rays, like Manta Rays, are definitely open ocean or pelagic rays. But this one that we're looking at, the cownose ray, we said will definitely swim out in open ocean. It will hide in the sand too, especially when they're smaller. So when rays are babies, they're very little cute animals, but they have to protect themselves. So they have two different ways to do this. They can hide in the sand, or they can use their counter shading. So if you notice, there's this dark color on their back and this light color on their belly. This is a form of camouflage that a lot of animals in the water have, where if your underside is lighter, you can try and hide when you're sitting above something. If you're sitting below them, the darker color to your back makes it easier to hide underneath something. So they'll hide in the sand, or they'll use their counter shading. Even as adults, they can use their counter shading. So a lot of rays like to be in the ocean floor, but other rays will be out in the open ocean. And one of the things you can tell where they like to be is this cute little smiley mouth they have. So the mouth of some fish points forward, the mouth of other fish points upward, and the mouth of fish like this point down. That tells you where they're going to get their food from. When we feed our cownose rays, they actually have to be on a surface. They can't just freely eat out of the open water because it's harder for them to grab their food. They would be normally feeding from the sea floor, so that's why they would often be found on the sea floor. But they can swim out in the middle of the water wherever they want to be, but they have to grab their food from underneath them. So here's a video of cow-nose rays feeding. This plastic panel we put in the water so that they can swim up to it. We can lower the food down to them, and it makes it really easy for them to grab their food. Now, the other cool thing is you can see right underneath their eyebrows, it looks like they don't have actual eyebrows, right underneath what would be eyebrows, there's this extra flap. Let's keep watching our ray feed video and see if we can figure out what's going on. Why would they have that? What's the importance of that? So now we get a different view. As you see them come up, they are very splashy. Soon as they get close to our aquarist, that extra flap kind of comes down, and it creates a better seal around the surface. They can also use it to kind of ruffle the sand if they're feeding from the sea floor, ruffle the sand to unbury their prey. But it helps create an area where they can grab their food underneath where their face is at and swallow that food. That's a pretty cool adaptation that some of these rays have. Yeah, so these flaps underneath their eyes help them eat. Helps them unbury food, and it can help them get the food into their mouth. Because if you don't have hands, it's pretty hard to get the food in your mouth. Think of like a pie eating contest. If you had special flaps to hold onto the pie on your face, that'd make it really easy to eat. But not all stingrays have that. This southern ray does not have those flaps. In fact, what you might consider like more of its face is farther back from the front of their nose. So not all stingrays have this adaptation. That's a really interesting thing to keep observing, is that even though they have very similar bodies, there's a lot of differences that you can notice. Now, what do you notice is the same between this ray and those cow-nose rays? I can see two things that are pretty easy to connect to a cow-nose ray. Do you remember what we talked about with coloring? So a dark back and a light underside? That's counter shading. So a lot of stingrays, a lot of fish and sharks all over, even penguins, have counter shading. What's another thing you remember the Fiddler Ray having? What do we look for while it was hiding in the sand and in the dirt? The nose and the back of their head. There it is. So that cavity right there is the spiracles, where they can suck water in. They can actually spit water back out that way too, but mostly you're going to see them sucking water in so they can help get the water to their gills underneath. So a question of where our rays in the food web came in. Rays are not necessarily the top of the food chain or the food web, but in some cases they are. There's not much that's going to eat a stingray, especially the really large stingray. So this southern ray might be easily 50 to 80 pounds, which doesn't seem like a lot, but it's a pretty big animal. This could easily be about 3 feet wide and about 5 feet long. They're a big stingray. They're pretty powerful when they're in the water too. This is a lot of muscle that can move things around. When our divers are trying to feed the southern stingray, when they would feed them on the window during one of our presentations in the galleries, that diver can actually get pulled across the window because the stingray is just moving along. So they try to reach around, put the food in front of its face underneath, because its mouth is down here. Sometimes that diver will get dragged along the window, which I thought was kind of funny, but it makes it really tough for them to feed the animals. But they are pretty strong animals, and if they have this stinging adaptation to defend themselves with, not too many animals will try to eat them, especially as adults. Maybe as little baby rays, more things might try to eat them. But one of the few predators I know will feed on a stingray is a specific type of orca. They've learned how to hunt stingrays. Not a lot of animals have figured out how to do that. So there are some that eat stingrays, but not usually as adults. So stingrays are kind of mid to top tier animals in the food web. And some people are texting that they can see the spiracles. Good. That's a great observation. Some of these rays have very tiny spiracles, whereas our southern ray has actually some pretty large spiracles. That's pretty cool. I'm glad you observed that. Now, what are the... that was the other question about the predators. Okay. Well, let's keep exploring with some of our stingrays. What's the next stingray Carrie wants to show us? Carrie gets the true pancake of the ocean with the blueberries in there. In this lighting, you can't quite see that their body is actually very tan, and they have very bright blue spots. But isn't camouflage supposed to help you hide? Unless they're hiding in a stack of blueberry pancakes, why are they so brightly colored? Maybe they do hide in pancakes. No, they're not hiding in the pancakes. Why would then an animal have really bright colors? What do you think is important about having all this flashy color on top of their body? While you're thinking of that, here's the spiracles again. See, we're starting to notice some very similar body parts of our stingrays across the entire group of animals. Oh, someone's guessing that the color is for protection. Kind of, yeah. So if you have camouflage to hide, that's your protection. You're trying to not let anything find you. But if you have really bright colors, sometimes the message is, don't mess with me. They can be really, really dangerous to other things. Or maybe they're trying to pretend to be really dangerous. Sometimes that coloring is just a warning of, I could actually be really dangerous. You don't know, but you don't want to find out either. And for some of the animals, bright coloring is a false pattern of camouflage or false pattern of scariness. There's a lot of animals that pretend to look like other animals. But in other cases, some of the dots and stripes on these animals may actually break up their outline, so you still couldn't find them. Even though it's really brightly colored, if it makes it tough to see the outline of a stingray when they're swimming around, a predator may not be able to find them. That's actually the idea of what camouflage is for. If it's not perfectly hiding you like an octopus, the idea of spots and blotches and things all over is to help break up your outline so things can't recognize what you exactly are. So good job. Coloring is about protection. It just has a different job in different cases. Now, these blue spot rays are really fun. We have some of these out in our Shark Lagoon touch pool habitat. They like to hide under the sand. They tend to be a little shy and don't always come near the guests, but they have a very smooth body, except for they have a kind of a spiny ridge down the middle of their body. So sometimes stingrays even have thorny ridges like a skate would. So there's a lot of similarities when we start looking across the whole group of stingrays compared to what we might have expected them to look like. Let's switch into a big open ocean type of ray. Let's look at something that's more recognized like a manta ray or a mobile ray. They are open ocean animals. We call it pelagic. And their feeding process is very different. So their mouth, is it going to point forward or down? Which one is it? Is it pointing? Ooh, you can actually see all their gill openings right here too. So mobile rays and manta rays, is their mouth underneath them? Do they have to grab their food from the floor? That one it is. The mobile ray, the mouth is pointing forward. So they have to chase their food, but they're not chasing any big animals, they're chasing plankton. Whereas the reticulate whiptail ray has to grab its food from the ground like the other stingrays do. So non-stinging rays might have very different body designs and how they capture their food. So the biggest rays that are on the planet actually don't sting. That's the manta ray. They could be up to 20 feet wide. But they also eat plankton. Now that's an interesting coincidence because the biggest sharks on the planet eat plankton, like the whale shark or the basking sharks. They're some of the biggest animals that we have in the ocean, in the shark and ray family. They don't eat the biggest food. They eat the smallest stuff. Now, good observation. Somebody found out that the manta rays and mobile rays have their mouth in front, kind of like we do. So if we had to get to our food, like we can move our head around to get to our food, but if your head stayed in one spot and you went this way, you'd have to be chasing after your food and hope it gets into your mouth. But if your mouth points down, you have to grab it from the sea floor. Good observations, everybody. Well, let's see if we can start connecting the dots to the exhibit we started with. What adaptations have we discovered so far today? Mouth direction, coloring, the stingray's trying to block the camera. There's one of those Kaunos rays. Do you see the Kaunos rays always sitting on the floor? No, they're pretty open ocean animals. They'll swim around wherever they need to, just like the eagle rays will. But their coloring helps them hide even out in plain sight. Now, this is the actual... Actually, it disappeared. Well, there it is. That is an actual eagle ray. That's its name. But there's also a group of rays that are just the eagle ray group. Things like bat rays belong to that, too. The Kaunos rays belong to that. Any of the rays that essentially look like they're flying underwater are the eagle rays. Just like a bird flies with its wings. You saw me doing that earlier, yeah? This is a true eagle ray. So they're looking like they're flying while they're underwater. That blue spot ray is more like if you ruffle a sheet. So it's called undulating. So it does this with the sides of its fin. So its pectoral fin, instead of flapping big motions, kind of undulates. So that's kind of a difference in some of the rays too, is how they swim. The big flapping motion is great for open water, like the bat rays, the Kauno's rays, the eagle rays will do. But this ray is less likely to be out in the open water, out away from the sea floor. They will tend to be on the floor because of how they swim. So a couple other things that people have noticed is the wing-like motion. Good. Thanks for texting in your observations. But remember, yes, they do all have cartilage skeletons. We can't recognize that necessarily by watching them, but we do know that about sharks and rays having a cartilage-based skeleton. Ah, good question. Why is the eagle ray nose so pointy? Well, let's go back to a picture of the eagle ray. Their nose is really important for how they feed. It's the eagle ray smiling. This is how they smile. You can actually see their teeth right here, too. Their teeth are not perfectly flat like a bat ray's are. They have some texture to them, so they can grab and hold on to their food. But their nose is useful for digging into things, getting into spaces to get to their food. Remember the Kauno's ray has that flap under its eye to help get to its food? So the face shape for some of them is really important. Or they have different appendages or designs to their body because of how they're feeding. So while their mouth is underneath, just like the southern stingray or the bat ray, this animal will use its nose to help it get to its food. The way that we feed our eagle rays here is we actually use, like, almost think of like a tiny little orange cone that you might put in the sidewalk. Like, oh, don't walk there. We've cleaned it, made sure it's perfectly clean for them, but we invert it and we use it as like a little cone that it puts its face into to get to its food. So it uses its nose to help it get to its food. And that feeding process we use is called a targeted feed. So we know we're feeding that one particular eagle ray rather than it just generically would steal food from anybody else. Ah, someone asked, do animals at the aquarium have picture day like we do at school? If you would consider trying to get picture day like watching a bunch of 6-year-olds do play a soccer game, yes. Because they don't wait in line, sit there and like, tilt your head. Next. The animals are not patient with us. The animals just kind of like, you want to get my picture? Oh, wait, no, I'm going to go this way. Oh, wait, nope, no, nope, nope. The animals just do what animals do. But we have some really good photographers that are really, really good at taking pictures of our animals here. So some of them are paid staff, some of them are volunteers that have taken pictures of our animals. And we're lucky enough that they share them so that we can share them with you, all the cool things that our animals do. Now, there's actually a lot of content on our website that you can check out all our fun pictures. We have some blogs on our website that you can look at from the past of our animals and our staff working with them. We have updates about animals. We have our online learning center where there's a lot of information about the animals that we have here. But you can also check out a lot of our stuff we've shown in the online academy. So if you go back through all of our playlists in our YouTube page, you can find all these different videos with so many cool pictures of our animals. All right, well, we have a few minutes left. What should we do next for rays? We should talk about a special group of rays that really needs a little bit more attention. Those are the Rhino Rays. Looks just like a rhinoceros, doesn't it? Almost, sort of, yeah. They have thorny ridges on their back, but this is where some of these animals used to be considered something like a shark or something else besides a ray. So let's compare. What's different about, okay, let's start with the similarities. What is similar between this animal and other stingrays? Because there's a lot of differences. So let's start with the same things. Spiracles. The spiracles again. They all have spiracles. Can you find the gills for this animal? If it's a type of ray, where are the gills? If it was a shark, they'd be right there on the sides. But this is not a shark. So the gills are underneath. Okay, so we can't see the gills in this picture, but it has them. Now, what's different? That's a big list. There's a lot of differences. Their pectoral fins, their dorsal fins, their tail even looks like a shark. It's like you glued a shark and a ray together and you made an animal. Nature's very fun and different and how it tries to create things. So the Rhino Rays have very similar body plans to things like sawfish and guitarfish. But then there's some very exotic body styles like this one, where the front half exactly looks like a ray and the back half looks like a shark. Well, the reason that we want to talk about them is because Rhino Rays are all threatened or endangered. But why? Well, they're getting caught up in fishing gear. They're bycatch. They're not intended to be the one that's getting caught. People trying to catch seafood. I like seafood, so it's okay to eat seafood, but if we don't fish for it responsibly, we sometimes catch the wrong thing. Now, it's tough for us to help in that way, where it's like, I'm going to choose this seafood item versus that one. Because the reason that they're endangered is for the local markets. So it's not for a regional thing, like they might import their seafood to us. It's more about the people that are only feeding the people in the immediate area that these animals are found. But if we know that this is a thing, we can make choices about how we support animal research and animal conservation. So that's where we have our abilities, is to do more to educate others and to also support them in some very non-conventional ways. So that's the Rhino Ray. Now, I challenge you to go look up some pictures of Rhino Rays, sawfish, eagle rays, manta rays, whatever kind of stingray you want, and start comparing and contrasting their bodies. What do their bodies look like? What abilities do you think that they have? Where do you think they eat? Because all the different tricks we've learned today about how to tell all these different things about them will start to make sense when you start looking at more pictures of animals. Okay, well, let's go back to... Actually, we haven't looked at Shark Lagoon yet. Let's look at Shark Lagoon. Shark Lagoon is one of our other large exhibits. Here's a picture of our bat rays. So while we're pulling up our webcam for Shark Lagoon, this is a local species of California. Remember, we have counter shading. I can see the spiracles behind their eyes. We can tell where their mouth is at. We know it's a ray because the gill openings are on their chest. So there's a lot of similarities that we learned among all the different types of rays. Let's check out what's happening out at Shark Lagoon. We have a couple of stingrays out at Shark Lagoon, along with our sharks and a bunch of our fish. Unfortunately, our big stingray's tail is right there. So she's hiding just underneath the camera. So her tail's right there. She's actually a very large fish. She's their biggest animal, or at least their biggest fish right now. She's 10 feet long, 6 feet wide, and about 400 pounds. Definitely the biggest fish. She's, I think, second only in size by weight next to Parker, our 800-pound sea lion. So she's quite large. We have a zebra shark hanging out right here. We have our blacktip reef sharks, our gray reef sharks, and there is a mangrove ray in here, but she's hiding too. So when you look out at all the sharks and rays, start looking for comparisons. Start using all the fun things we learned today about rays, what makes them similar to sharks, but why are they so very different from sharks? And think about all the different things that you notice about our other fish we have in these tropical habitats too. So stingrays can live in tropical, temperate, and cold water habitats, which is why we have bat rays here. We're considered a temperate habitat here in California. We have one more question popping in the studio, and then we'll let you all explore more on your own. Somebody asked, do sharks eat rays? I think that they do, but it's not all the time kind of thing. You'd have to be a big enough shark to hunt a certain kind of ray. And remember, stingrays have that stinging ability to help them defend themselves. So you have to learn how to do it. That's why only some orca actually eat stingrays, because not all of them will have learned how to do it. So there are some cases where sharks might eat rays, but it's a specific kind of shark. It wouldn't be necessarily this shark. They like to eat crustaceans and other small fish and things that are on the seafloor, but nothing as big as a stingray. So sometimes they might, but it's not very common. Good question to end out our days. Like, well, if they're so closely related, would they actually try to hunt each other? Not usually. Well, my friends, have some fun exploring on your own. We're going to be back tomorrow at 9 a.m. for more of our Summer Kids Club in our Aquarium Online Academy. So tune in tomorrow if you want to learn more. And then we'll have a new team of educators to help you out too. Have some fun, my friends.